Mr. Bowers.
Yeah.
Is that a penny?
It is a penny.
No way. I got it.
It is a penny.
Yeah.
What has a head, a tail, is brown, and has no legs?
Could have said rattlesnake.
The answer is penny.
There's a lot of
It's
answers.
a turd. It could also just be the letter I, but with.
So yesterday, we finished.
Oh, is this the four-headed tail?
Copper color.
All right, I got the answer. We had this one yesterday.
Oh, yes. He was.
Because he was anti-money.
Antimony.
Oh, that is so stupid.
Was the
I didn't even know that was an element. That didn't even sound right.
anti-money.
Opposite of
Anti-money.
What's the atomic number?
Antimony, AT, or no, that's astatine. Hold on.
SB, I thought, 51.
51.
Yeah, 51.
I don't know. Not always about that. That's the only reason I remember it is because like antimony is SB. Yeah.
It was tricky.
Surprised I remember what the
All right.
atomic number was. Yeah.
Yes. It's a great idea.
My fingers moving, I just got blood
Oh.
all over my hands.
Oh, I was gonna say, you can use my things.
Oh, man.
Oh, okay.
It's up to you. I don't care. So I got a few things. Not a big passer out fan. I've been collecting things for a while. So I'm gonna pass out some papers real quick. Just to get this out of the way, you know?
What a swell idea. You should put a goat video on when
You guys ready?
You should put the goat video on when you do it.
The goat video on while I do it.
Hey, Mr.
That is a
Bowers,
great idea.
I thought I turned this on.
Take it. Thank you, sir. And here, Josh, we're doing this quick like, in a quick like manner, you know? Speed walk. Oh, sorry.
Sure.
Tommy. Oh, he's over here. It's far away.
Everyone missed it.
Oh, I thought I was gonna get more off.
I think everyone just missed it.
Not everybody.
Oh, really? Oh, he didn't bother to tell us. That's 2 points. What the heck? You guys like me, that's not good to drive. Let's see.
It's entirely different.
Josh.
Right.
Next.
I forgot to write down. I'm an idiot. Yeah, we wanted to book it in town and we forgot.
Now, for the homework, as long as you guys attempted each problem, I gave you credit. If you guys checked plus, you got full credit.
Oh my God.
Okay, I left copy.
Josh is back here. Jill's over here. Give me a second. Brady.
You know what sucks? Is I knew as soon as I walked up.
Awesome. Woo! We survived. All right. That was a lot, yes.
This doesn't add up. So how do you get 2%?
Right, so what I did here was, well, I was mainly focusing on the angle, but the angle has 360 degrees. All right, so what I did was I took it out of 360 because if you had a higher angle, if you were at like 289 and you were at like 295, that's 6 out of 295. That's unfair to the people who's like 3 and 7. If you're at 3 and 7, 4%, 4 out of 7 is 56%. Does that make sense? Yeah. So I was kind of trying to do it fair so that if you're like, I took how many percent you are over 360 instead.
Okay. That works.
Yeah.
But what about the length?
I didn't do percent error on the length. All right.
Mr. Josh, can I rant slash vent about pre-calculus?
He vented.
You want?
Well, like the issue is like we're doing the same thing. We're
You know-
doing the same thing with vectors, but it's called headings and bearings.
Oh my gosh.
And so it's what makes it annoying is that like you know how we start on like what or we start on the east and we go around blah 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 blah. For some reason they decided that they would start at the north and you would go all the you have to go all the way around and that's
Oh,
how you
no.
define. Instead of just doing like if it's close to the it's close to the like negative x-axis, you just do that angle. It's really confusing.
Yikes.
I think you should email our chair, Ms. Wilmore, and sort of don't have to take the.
No, dude.
All right. All right. So I did push the test back to Friday. So
When was it gonna be?
tomorrow.
Today.
So we are going to finish the note. Well, get close to finishing the notes today. And have more like a review tomorrow. I feel like a review would be good. All right. I don't usually do too many reviews, but I feel like a review for tomorrow would be good. Yeah.
We should review the go.
Great idea. Great idea. Maybe later, you know? That's kind of my motto.
I thought your motto was if you know what I mean.
Yeah, that is my motto, if you know what I mean.
So later is kind of your motto.
It's up to you.
There can be multiple mottos, right?
Yeah, of course. All right. So I am going to go over this for a little bit. And then I got my bottle flip contest I've been practicing all day for.
About that.
Nuh-uh.
I'm gonna get like 0. Okay, so I was nailing it, and then my mom's like, you should put more water in it. And so then I did, and then I like can't hit any. Ate it.
Well, drink some water.
Well, I did. I couldn't find it. Do you not even have a bottle with you?
You need someone to fight.
Are you serious?
Oh, I always come prepared. How much water do you need in it?
I'll figure it out. I'll start practicing.
Here.
There's a very scientific way of it.
There you
That's
go.
actually like perfect. That's about exactly.
That is perfect.
That would have been amazing if it's like,
I know it's perfect. No.
Oh, what are you talking about?
Stop making.
All right.
what's the viscosity of this liquid?
I swear.
All right. So we should be on relative velocity number 13, a railroad flat car. All right. Everybody see where we are down here? So a railroad flat car, this is relative velocity, right? Railroad flat car is traveling to the right with a speed of 13 meters per second relative to an observer standing on the ground. Okay, so from the ground, you can see the picture. It's traveling to the right 13 meters per second. I'm just writing this down here. Okay. What is the magnitude of the velocity of the motor scooter relative to the flat car if the velocity relative to the observer to the ground is 18 meters per second to the right? So, wait, hold on. Relative to the flat car is traveling. What magnitude of velocity for the motor scooter? So, if the motor scooter looks like he's going 18 meters per second. He looks like he's going 18. He's on a vehicle that's traveling, or on a train going 13. So how fast is he actually going? 5. He is on the train. Can you see him right there?
That's not a pile of rock, that's a guy.
Can you see him right there? So the answer is 5. He is only going 5 meters per second. Okay.
That's impressive.
Riding on a train, that is pretty impressive.
Oh, no, I was just gonna say, like, going that slow on a motorcycle.
Oh,
Motor scooter.
okay.
It's a scooter, you know?
So
Motor scooter.
now, once again, he's on the flat car traveling 13 meters per second. However, what the observer sees is him going 3 meters per second to the left. Okay, so now I have to add these two. So 13 plus 3, 16 meters per second. However, what direction is he going? Left. What's that mean? Negative. Or you could have put left. Does that make sense? All right. And what if the magnitude is 0? So he's going 13 meters per second this way. And it looks like he's not moving. All right. So it looks like he's not moving. All right. So how fast is he actually going? If it looks like he's not moving, he has to negative 13 meters per second, right? Because if he's traveling at 13 meters per second and he's going negative 13 meters per second, it's like he's not moving, right? It's kind of like going up one of those stair lines, or what a escalator. Thank you. But you're just kind of walking at the pace of the step. You're not going anywhere unless you go faster or slower, you know. Does that kind of make sense? Relative velocity. All right. All right. Ooh, there's a lot of words on this slide. Let's see what we got. All right, 2 piers. Oh, something different. 2 piers. All right. A and B are located on a river. B is 1,500 meters downstream from A. 2 friends must make round trips from pier A to pier B and return. One rows a boat at a constant speed of 4 kilometers per hour relative to the water. The other walks on the shore at a constant speed of 4 kilometers per hour. The velocity of the river is 2.8 kilometers per hour in direction from A to B. How much time does it take the walker to, how much time does it take the walker to make it round trip? Yeah, right? All right.
How much time do you got, dude? All the time, dude.
All the time.
Every other time.
All right. So how much time does it take the walker? So let's talk about the walker. So the speed of the walker is 4 kilometers per hour. Speed is 4 kilometers per hour. Okay. Now, what else do we know? We know his distance, right? How much does it take him to go down and back? 3,000 meters. Very good. Okay. So what's my speed equation from unit 1? Speed is equal to distance over time. Very good. All right. So if you have 4 is equal to d over time, well, 3,000 over time. When you do your unit conversions, you're going to get time is equal to 3,000 over 4. All right. And the answer should be, well, I guess. I converted to hours. 3,000 divided by 4. Anybody got a calculator on? 750? Where'd I mess up? Time.
Because he's going kilometers per hour.
I tricked myself.
Yeah, I did that too, right?
I tricked myself. 4 kilometers per hour, so 4,000 meters. Holy smokes. Good start to the Wednesday.
Only Wednesday.
Yeah. So 4,000. So your answer should be 0.75 hours. Okay. We're good. We're good. We're making it. We're making it. There we go. Now, all right, how much time does it take for the rower to make a round trip? All right, this is a little trickier. All right. So let us see. Now, we're going to have to calculate 2 different things because he's one of the trips, he's going to be going with the water. The other trip, he's going to go against the water. Right? All right. So I'm going to kind of separate this into 2 different calculations. All right. So when he is traveling on the water, he is traveling with a constant speed of 4 kilometers per hour. So speed is 4, I'm going to say 4,000 before I make another mistake. 4,000 meters per hour. Okay. Then it tells us the velocity of the water is 2.8 kilometers per hour traveling 2.8 traveling in the directions from A to B. So it's adding to his speed. All right, so he's adding 2,800 meters per hour. Okay, so that equals 6,800. All right, so my speed is 6,800 meters per hour. I'm running out of space. I don't know about you guys. 68 meters per hour. And we know the distance, right? We know the distance, so we're going to calculate the time for this. So the distance is 1,500 is equal to this. Wow. Oh my gosh, I'm really messing up. Speed is equal to distance over time. And when you solve for t, I got t to be, let's see, 0.22 hours. Is that what you guys got? Okay. So I got 0.22 hours. Now on the other direction, all right, he's still traveling at 4,000 meters per hour. However, this is going to be a subtraction, right? The water's going against him this time. All right. So we're going to subtract the 2,800 meters per hour. So I get a total of 1,200 meters, right? So that's going to be equal to the 1,500 over t. You guys following so far? So my time here, once you do your conversions, I got a time to be 1.25. Okay. And then you just combine your 2 times. Okay. So I got an answer of 1.47 hours. So clearly it was a lot faster to walk. But rowing was probably more fun. Rowing was definitely more fun. All right.
Very slow walk.
So we're kind of applying what we learned from last chapter into this one, right? But we're still talking about relative velocity. All right. Any questions on that question? Yeah.
Well,
Why isn't it just like the same amount of time? Because like the resistance is working one way out and the other way another. Oh, it's because it's okay. Never mind, I got it. I was trying to do it based on distance and not time. My bad.
Fair enough. You're good. All right. Now, we're going to talk about some unit vectors. All right. We're going to do some good old conversion. All right. Not conversions, I guess. Adding and subtracting x and y's. All right. So we kind of already touched base on this idea. So that's the definition if you want to write it down. I'm just going to go to the next example. All right. You're just adding two vectors. All right. So you add your x's and you add your y's together. It's as easy as that. Right? You don't need to write down that equation. It's kind of confusing, honestly, but might make sense. All right. So we're going to walk through this next problem. We're going to walk through this problem together. All right. Example 15. Given the following displacements, find the sum of 2d minus e. Okay, so I know d is equal to, you know what? I'm going to make this big screen. All right, I know d is equal to 6x plus 3y. I know e is equal to 4x minus 5y meters. Now, what this is going to look like to find the sum, I have two d's, right? I have two of them. So how many? I just going to convert. So I have 12x plus 6y m. And then my e stays the same, correct? Now, when you subtract them, this is where it gets a little interesting. I mean, a little. All right, you have 4x, subtract e, 4x minus 5y, m. So inside my equation, I'm going to change this to a positive because that's what I like to do. So that's going to be a negative 4 and a positive 5y, correct? All right, so what is 12x minus 4x? Nailed it. 6y plus 5y? That's your answer. Whoa, indeed. Like, it's kind of fascinating. Yeah. All right. Does that kind of make sense? Now, find the magnitude and displacement of this angle. Oh, find the magnitude and displacement. This is a little tricky. Anybody got a clue on how to do this? Graph them. Love it. All right, so I have a positive 8. I have a positive 11 in my y direction. All right, so my goal is to find this magnitude and displacement, right? All right, well, to find the magnitude, just a squared plus b squared equals c squared. That's pretty easy. What do I do with my calculator? A squared plus b squared equals c squared. So I got 8 squared plus 11 squared. Take the square root of 185. I got 13.6. Bless you. 13.6 meters. Is that correct? Everybody getting that?
Correct.
All right. Now I got to find theta. Oh, once again, I'm going to SOHCAHTOA. SOHCAHTOA. I guess I can use any of those, but I like to use tangent. So tangent of theta is equal to the opposite over the adjacent. Okay. So what you actually have to do is take the inverse tangent to get rid of that. So the inverse tangent of 11 over 8.
You should get 53 points.
Just going to double check real quick. 53.97. Does that make sense? Hopefully we kind of picked that up from our graphing vector lab. All right, we got a lot of practice on that. So Katoa. Any questions on that type of problem? Yes.
Would you like me to determine significant figures for this?
This one, X, Y. So Katoa. 2D. Let me think. You have your 2, you got your magnitude, tangent of theta. Yeah. Yeah, I'm trying to think. Yeah. So 1 sig fig, so it'd be 50 degrees. Yep. Very good. Okay. Yeah.
Do you have to do the like north and east or whichever one?
Not if you just say 50 degrees, here's my 50 degrees is like that. So I don't have to. Like if you just say 120 degrees, you can just say 120 degrees. You don't ever have to do north, east, west unless you feel comfortable with it. All right. Next question. I want you guys to try it out on your own. All right. Similar example here. Similar example. Just a little bit more difficult. Got a negative thrown in there. -4f. As you guys are trying it out, I'm going to be working it up here. So there's the first part. Second, we got to graph that. So be careful with your negatives. Four squared plus 14. Well, I guess it's gonna be 70. Huh? All right. Is this what everybody's getting? So I got negative 4x minus 14y. Then you got your m. All right. When you plotted it, you did a squared plus b squared. I got 15. Including sig figs, I had 70 degrees. Is that what everybody's getting? Yes.
How do you know how to do sig fig?
So on this one, division, there's only one sig fig. This has 2. You do whatever's less.
And like for the Pythagorean theorem, how do you like know the yeah, what is 15 feet?
So what I did was,
What the Pythagorean theorem would be like, you add up the square roots, it's then be the sig figs of the square roots. Or the squares.
you add up the squares. So 14 squared plus 4 squared. All right. 14 squared is 196. No, 14 squared. Yeah, 196. So plus 4 squared is 16. When you're adding, remember you take your least decimal. So you take the full 212. I guess there's, wow. I should have taken 3. I should have taken 3. That is my bad. I'm getting, I got 14.6.
Man, we just gotta abolish sig figs.
No, that is correct. That was my bad. Yes.
Why is it 7 degrees and not 250 degrees?
Yeah.
It should be in the third quadrant.
70 degrees. Oh, south of west. So you could have got 250. Is that what you got? 250.
I got 240.
Yeah. Okay. How we all doing? Starting to kind of make sense? Adding vectors. Have you guys seen this before?
Probably at some point.
Somewhat?
Similar to other things.
All right. Do we think we got one more in us? One more practice, adding 3 different vectors? I think we are ahead, so we're going to keep going. I think we're crushing this right now.
Wait, you just need to do the bottle.
Yeah, you need to do
You
the
bottle flip.
Okay, you guys have.
I got both. I got both in me. All right, so 4f. 4 at negative 6x 3y plus 2g's minus 2h's. Woo! Got a big one.
It is.
Negative 24x minus 12y. Wow, it is going to be very negative. Negative 34, 44, 48. Negative 12, negative 16, negative 24. Is that right? You got that? Just don't feel like using my calculator right now. 48, 24. 48 squared plus 24 squared 3 sig figs, 53.7. So TOA. So inverse tangent of opposite over adjacent. So inverse tangent of 0.5. Okay. 2 sig figs. This will be 27 degrees south of west. Or you can have 207 degrees. Or 207.
Okay, that wasn't that
Not bad. See, we nailed it. Yes.
Bro, you have 207 degrees, and that would make that 3 sig fig, so you have to write it differently.
Yeah. Yeah. So in this case, you would have 210 if you wrote it in that version.
Don't you add the 180, and then you just go decimal point?
No, you would have, I see what you're saying, but like 27 degrees that way, it's still 2 sig figs. Even though like you're adding the 180 shouldn't be a part of it, even though it is. It should still be 2. We start to feel comfortable? Yeah. 2 sig figs?
You guys, okay, so like on the last problem, it was 2 fills, so the 3 sig figs, like the A stroke was 3 square. This one, it's like 2, it's like 2,000 something.
2,880. That's what I got. So the 2 counts, the 8 counts, the 8 counts, that 0 does not count. All right. That's all we're doing today. We're feeling pretty good.
I don't need to warm up.
Warm up. I do not got time to warm up.
Mr. Brower, hold on.
Yes.
I believe we should be able to take that. I mean, you think it's gonna win? Because I have no faith in this. I have no faith. 5 extra turn points on this round.
Wait, we all get an extra point on the test.
You gotta
I
know.
feel like that's about
They have to choose one.
You gotta know. I'm a physics teacher.
He knows.
That doesn't mean you can apply it.
Isn't this your first year teaching?
Let's make some water bottle toss.
It's not even water in your
Wait, that's not water.
How many are we doing? 5 clips?
Wait a second.
Hey, we're doing a water bottle toss. Hey, there's Hannah.
Hey, it is a water bottle, it doesn't have water in it.
Wait a second.
Is it a water bottle?
Oh,
He's cheating.
Ha!
Practicing. Practicing.
That actually counted.
Yeah.
Wait, can I try that one?
Oh no. Oh no. Oh no.
Alright, I bet black.
Oh no.
Wait, can we do like a water competition? Should we do
like a double play?
Yeah, we should have been
Yeah, man. Wait, we should do that.
How are we doing? I think I won.
Do it again.
No, do your
I think you.
Okay, wait. If he wins this, we all get an A because you are cheating.
I didn't cheat.
Yes.
That's not water.
That is not water. It's a water bottle. And
then
the water has to be full of
That wasn't in the rules.
on water bottle.
bottle full of sand salt. You guys have to use the same bottle.
No, it's a bottle.
Oh,
It's a bottle.
3 of this, 2 of that.
Mr. Bowers had 8 throws, he sunk 7 of them.
You just have to
If
land
could
8
hit
in a row.
all 8.
You just have
Aiden,
to land 8.
all 8.
You can do it.
All 8.
I believe in you, Aiden. That's
Aiden,
okay. No, it isn't.
I'm pointing up to the first 2.
No,
I'm
you
gonna lose
aren't.
the first 2.
No, you aren't. You got this, man. Yes.
Oh.
Got a tie.
Go for it.
Oh, six.
Oh,
I'm safe.
oh.
Let's see if he misses this one.
I had it. I had it.
I want to see that.
That was actually my way. That's a foul. That's a foul.
My bad. My bad.
I believe the water bottle.
Aiden,
Oh, no, wait, I go first.
It's
Like that,
doesn't
you
get
get
in
3,
the
it
water
really doesn't.
Every time.
Like it
Let me
isn't
try
perfect, like you still have to like try. That's weird.
I had it down, nice.
You can't get it every time.
That would be tough to
the
be
bottom.
Wow.
You gotta come prepared.
That's cheating.
No, it's not cheating. It's kind of like you just gotta be prepared for the fight, you know?
Oh, it works.
The battle. Now the double flip is really hard. Really hard to get it over twice.
Well, that one.
Wait, I kind of want to try once.
Yep. The single or the double.
Hey,
That's how I work on how much
yay.
water in this case. That's a great activity. Have a good one.
Matthew Johnson, can you take us out to the police?